A planet that receives a signal from deep space surpasses all expectations and sparks a competition to reach another star. What if everything we thought we knew about the universe is about to be shattered? The James Webb Space Telescope, JWST, has discovered shocking secrets that could rewrite the rules of life itself. But is Proxima B truly a new Earth, or a dangerous trap? In the vastness of space, the James Webb Space Telescope, frequently hailed as the most advanced structure in space, has recently shifted its focus to one of the most exciting exoplanets ever discovered, Proxima B. This distant world, circling Proxima Centauri, a red dwarf star, has captivated scientists and enthusiasts alike since its discovery. Now, with the exclusive capabilities of JWST, we are finally getting a better understanding of this enigmatic planet. Initially, Proxima B was not thought to be extraordinary. First discovered in 2013, it wasn't until the James Webb Space Telescope came into the picture that we could truly appreciate what lies on this distant world. The telescope's ability to capture infrared images has allowed astronomers to peer into Proxima B's atmosphere, revealing details that were previously hidden. What has been found has sparked both excitement and concern. You see, Proxima B orbits its star at a very close distance, less than 7.3 million kilometers away, less than 5% of the distance between Earth and the Sun. As a result, the planet completes its entire orbit in just 11.2 Earth days. What makes Proxima B even more fascinating is that it orbits a red dwarf star. Unlike our Sun, red dwarfs are well known for their volatile nature, frequently emitting powerful solar flares that can significantly affect orbiting planets. This is where things get more complicated. JWST has provided the clearest view yet of Proxima B and revealed some startling features. First, the planet is about 30% more massive than Earth, which means it has a stronger gravitational pull. But what's truly shocking is the possibility that Proxima B is tidally locked to its star. This means one side of the planet is constantly illuminated while the other is in perpetual darkness. Imagine a world where the sun never sets on one side and never rises on the other. This tidal locking creates an extremely harsh environment for any potential life forms. The side facing the star Proxima Centauri would be scorched by constant radiation, while the dark side would be a frozen wasteland. This brings up a significant question: could life ever survive in such extreme conditions? The possibility seems slim, but nature has a way of surprising us. The difficulties don't end there. Proxima Centauri itself poses a significant threat to the habitability of Proxima B. JWST has revealed that the star is far more active than previously thought. Its powerful magnetic fields and intense solar flares bombard Proxima B with high-energy radiation. In fact, an observed flare in April 2021 was 100 times more powerful than any flare ever seen from our Sun. Such a massive burst of energy could strip away the planet's atmosphere, leaving it exposed to the harshness of space. Some researchers argue that due to this proximity and frequent solar flares, life as we know it is unlikely to exist. Others suggest that life might adapt to these extreme conditions. Could there be organisms on Proxima B that have evolved to survive in such a volatile environment? Or is the planet doomed to remain a barren rock? As we continue to explore Proxima B using the James Webb Space Telescope, more secrets are sure to be uncovered. But one thing is clear: this tiny planet, just 4.2 light-years away from us, is far more complex and enigmatic than we ever imagined. Could it be that Proxima B holds the key to understanding the limits of life in the universe? And if so, what implications does that have for our search for extraterrestrial life? Proxima B's dazzling secrets were made public, and one of the most shocking discoveries was the planet's atmosphere, or rather, the potential absence of one. The severe radiation from Proxima Centauri, combined with the planet's close orbit, means Proxima B receives an incessant stream of solar wind and high-energy particles. Over time, this relentless assault could have stripped away the planet's atmosphere, leaving it barren and exposed to the cold vacuum of space. But here's where things get interesting. Scientists believe that Proxima B might still retain a thin atmosphere, possibly consisting of heavier gases such as carbon dioxide or nitrogen. These could provide some protection from the star's radiation. The James Webb Space Telescope has given us the most detailed glimpse of Proxima B's surface yet, and what it has revealed is both fascinating and mysterious. On the surface, it appears rocky like Earth, but with significant differences. The side of the planet facing Proxima Centauri is probably scorched by constant heat, creating a barren landscape resembling a desert. Meanwhile, the night side of the planet could be a frozen wasteland with temperatures far colder than anything experienced on Earth. But the most intriguing possibility is found in a small strip of land that separates these two extremes, known as the twilight zone. This area, where day meets night, might offer more temperate conditions where liquid water could exist. The existence of liquid water is, of course, one of the key ingredients for life as we know it. Could this twilight zone contain a secluded oasis where life has managed to take root despite the harsh conditions elsewhere on the planet? Another stunning revelation emerged when scientists investigated the possibility of water on Proxima B. If water exists, it would likely be in the form of ice on the dark side, or small, possibly temporary, bodies in the twilight zone. The discovery that shocked many was the potential for subsurface oceans, similar to those found on moons like Europa or Enceladus in our own solar system. These oceans could be heated by the planet's core or by tidal forces caused by Proxima B's close orbit to its star. If such oceans exist, they would be an ideal location for searching for undiscovered life beneath the icy surface. Let's not forget the potential challenges posed by Proxima Centauri's magnetic field. This adds another layer of complexity to the planet's environment. Recent studies suggest the star's magnetic field could interact with the planet's core, generating its own magnetic field. This interaction might protect the planet's atmosphere from being completely stripped away, much like Earth's magnetic field protects us from the sun's radiation. However, the situation on Proxima B is far from simple. The star's powerful flares could overwhelm the planet's magnetic defenses, leading to dramatic and sudden changes in climate and surface conditions. These discoveries raise more questions than answers. Does Proxima B have a magnetic field? How strong is it? How does it influence the planet's atmosphere and potential for life? Could life have evolved to survive Proxima B's fluctuating, hostile conditions? And if life does exist, what form would it take? Would it be entirely different from anything we've ever seen, or might it share similarities with extremophiles that flourish in Earth's harshest environments? Proxima B is a hostile world where life faces extreme challenges. Yet, the idea of a habitable planet in the Proxima Centauri system is far from science fiction. Despite the many challenges, the idea that Proxima B could harbor life continues to drive scientific curiosity. The very extremes that make the planet seem inhospitable might also be the factors that push us to redefine what habitability really means. Scientists are now using JWST not only to study Proxima B's atmospheric composition and surface conditions, but also to search for potential biosignatures, subtle chemical clues that could hint at biological processes. These include traces of methane, oxygen, ozone, or other complex molecules that are often associated with life on Earth. However, interpreting these signals is no simple task. Abiotic processes, those not involving life, can sometimes produce similar signatures. That's why scientists must proceed with caution, ensuring that every data point is verified and re-verified before drawing any conclusions. Even so, the mere possibility that we might be on the brink of discovering alien life is electrifying. What makes Proxima B particularly compelling is its proximity. At just 4.2 light-years away, it's the closest potentially habitable exoplanet to Earth. That opens up real possibilities for future exploration, not just through telescopes, but perhaps someday via robotic probes or even interstellar travel. Ambitious projects like Breakthrough Starshot are already envisioning sending tiny, light-powered spacecraft to Proxima B. These microprobes could, in theory, reach the system within a few decades, delivering the first direct observations of an alien world. But such missions also come with their own challenges, from propulsion and navigation to surviving cosmic radiation and transmitting data back across interstellar space. Yet, despite the technical hurdles, the dream of reaching another star system, of actually visiting a world like Proxima B, feels closer now than ever before. As we continue to learn more, Proxima B is slowly transforming from a mysterious point of light in the sky into a tangible, complex world with unique characteristics and untapped secrets. With every new discovery, it becomes increasingly clear that our universe is not only stranger than we imagine, it may be stranger than we can imagine. The journey to understand Proxima B is also a journey to understand ourselves, our place in the cosmos, the nature of life, and the future of exploration. Whether or not life exists there, Proxima B challenges us to think bigger, search farther, and never stop asking the deepest questions of all. Are we alone? Or is there something, or someone, waiting out there, just beyond the reach of our current understanding? The reality is far from captivating. Accommodating the James Webb Space Telescope has provided previously unheard of insight into the difficulties that any potential life on Proxima B might face, and anything other than rosy is one of the most accurate descriptions. The planet faces significant challenges, including exposure to extreme levels of radiation from Proxima Centauri. In contrast to our Sun, this red dwarf star has a much smaller mass and a far more chaotic surface. Its proximity to the planet indicates that Proxima b is bombarded continuously with intense solar radiation. Massive flares, up to 100 times more powerful than those emitted by our Sun, are common. These flares produce a lethal combination of ultraviolet and X-ray radiation that would be deadly to any form of life similar to Earth's. The effects of this radiation are not merely speculative. In April 2021, an especially large flare from Proxima Centauri was detected, strong enough to possibly eliminate any atmosphere that might have existed on Proxima b. This occurrence serves as a stark illustration of the dangers posed by red dwarf stars and casts doubt on the likelihood of Proxima b being a haven for life. Moreover, the constant exposure to such radiation would transform the planet's surface into an incredibly hostile environment. Any water on the surface would quickly vaporize, and the rocky landscape would be scorched. Heat that never stops on the planet's sun-facing side would be as harmful as the freezing temperatures on the dark side. This stark contrast between the scorching day side and the bitterly cold night side leaves little room for a stable, life-sustaining environment. The race to reach Proxima Centauri begins. While the signal from Proxima Centauri is still unknown, the notion of actually reaching the star system has moved from the realm of science fiction to genuine scientific ambition. The Breakthrough Starshot Initiative, led by a group of visionary scientists and supported by figures like Stephen Hawking and Yuri Milner, intends to send miniature, laser-propelled vehicles to the Alpha Centauri system, including Proxima Centauri, within our lifetimes. The idea behind Breakthrough Starshot is revolutionary, launching countless small spacecraft, each about the size of a postage stamp, into space. These starships would be propelled by powerful lasers, reaching speeds of up to 20% of the speed of light. The goal is to send these spacecraft on their decade-long journey to Proxima Centauri, where they could send back data about the star system and its planets, including Proxima b. While the challenges of such an endeavor are monumental, the potential rewards are equally vast. Discovering the true nature of Proxima b, whether it harbors life or is a barren, inhospitable world, could have profound repercussions for our understanding of life in the universe. What if Proxima b, this baffling and unpredictable world, holds the key to understanding daily life in the cosmos? The search for extraterrestrial life is one of humanity's most profound quests. But as we gain more knowledge about Proxima b and other distant worlds, we are forced to confront the realization that life may not unfold as planned. Proxima b may not be the Earth-like paradise we once imagined, but it could be a vital stepping stone in our quest for knowledge about the cosmos. The search for life in the universe is only just beginning, and Proxima b is leading the way. But the question remains, will we ever be able to uncover its secrets? Only time, and ongoing exploration by instruments like the James Webb Space Telescope and initiatives like Breakthrough Starshot, will tell. Perhaps Proxima b, with all of its challenges, is not just a planet to be studied but a glimpse into our future. The search for life, whether in our own solar system or on faraway exoplanets, reflects humanity's innate curiosity and desire to understand the cosmos. The discoveries made about Proxima b could shape the next generation of space exploration, providing crucial insights into the potential for life on distant worlds. Even if Proxima b proves to be hostile to life as we know it, the lessons we learn from this exoplanet could have profound implications for other planets out there. We may one day find worlds that are more hospitable, more like our own Earth, where life has found a way to thrive and survive in the most difficult of environments. The quest for knowledge will continue. As we push the boundaries of space exploration, we will no doubt solve additional mysteries that challenge our understanding of the universe. Proxima b serves, in the end, as both a symbol of the challenges we face in exploring distant worlds and a reminder of the amazing possibilities that lie beyond. It is a planet that may or may not harbor life, but its significance lies in the questions it raises and the journey it inspires. Through continued advancements in space technology, and tools like the James Webb Space Telescope, we are getting closer than ever before to answering one of humanity's most profound questions: are we alone in the universe? The pursuit of life may one day lead us to Proxima b, or perhaps even further into space's depths. And if we find life, whether microbial or something entirely different, we will have taken a monumental step toward understanding the vast and mysterious universe, most of which we are only just beginning to explore. Whatever the outcome, Proxima b will continue to be a touchstone for our ambitions, inspiring the next phase of research, science, and exploration for generations to come. As humanity stands on the threshold of a new era in space exploration, Proxima b serves as a beacon, both a challenge to overcome and a promise of what may lie ahead. Each discovery made about this distant world brings with it a mix of excitement and caution, hope and realism. While the presence of life remains uncertain, the importance of Proxima B transcends that single question. It represents a proving ground for our technology, our ambition, and our perseverance. To study such a planet, light years away, requires tools of extraordinary precision, international collaboration, and the willingness to invest in goals whose payoff may not come for generations. But that's the nature of exploration. It's never just about the destination, it's about the journey, the knowledge gained, and the doors opened along the way. As we develop better propulsion systems, more sensitive instruments, and new ways to sustain long-term missions, we move closer not only to understanding Proxima B but also to reaching other star systems. Each mission to study these worlds, each signal received, and each image captured brings us one step nearer to answering questions that have haunted humanity since the beginning of consciousness. Are we unique? Is Earth the only cradle of life? Or is the universe teeming with organisms, simple or complex, waiting to be discovered? Proxima B, in all its harshness and potential, reminds us that even in the most extreme conditions, there might exist the raw ingredients of life. And even if not, what we learn could guide future missions to more promising worlds. The stars have always called to us. Now, for the first time in history, we're starting to answer. And in that pursuit, Proxima B will not merely be a destination on a map of stars, it will be a milestone in the story of humanity's reach beyond its home planet. A world that challenges us, inspires us, and above all, pushes us forward. The story is far from over. In fact, it's just beginning.